Perfect. And let me actually do this one as well. Okay, perfect. So now let's look at, we have 4 different states, 1, 2, 3, and 4. So when both S1, so this is like, you see that why we're choosing this notation for naming our switches. The first state was when like S1 and S2 are both on. So if both of these are on, okay, so what's the voltage that we are gonna have on the load? This point, it's gonna be connected to, this is VDC, positive, negative. This point, it's gonna be connected to VDC, and this point, it's gonna be connected to ground, right? So like, let's just like have this ground here. So this is ground. So the output voltage, it's gonna be positive VDC. Right, so when S1 is on, S2 is on, our output voltage, it's gonna be positive. Let me actually choose a different color. Maybe that green was good. So this is gonna be positive VDC. Okay, now we're gonna keep S1 on, turn S2 off, and S3 goes on. So S1 is closed, and S3 is closed. So we basically have, just like our circuit is gonna be limited to the load, S1 and S3, and S1 and S3 create a short circuit here, right? It might sound weird why we wanna have a 0 voltage here, but later on when you calculate the RMS value, you'll see why we do that. So like, this is what we end up with. When S1 is on and S3 is on, we have a 0 voltage here. Okay, so, and in state 3, now S1 is off, but we still have S3 on, right? So S3 and S4 is now on, because S1 is on, S4 turns on, and S3 and S4, it's gonna be on at the same time. So S3 is on, so this is gonna be on, and S4 is on. So we have this node of the load connected to ground, and this node connected to positive VDC. Right, and because of the notation that we chose for our output voltage, so this is actually going to become negative VDC, right? So when S4 and S3 are on, this becomes negative VDC. Okay, the next state is when you have S4 and S2 on, right? S4 is still on. You see here, S4 is still on. S3, it's not on anymore, it becomes off, and we turn on S2. So S4 and S2 are on. When S4 and S2 are on, we basically have again a short circuit against the load, so the output voltage would be 0. This is 1 here. So the output voltage, it's gonna be 0. So this goes back to 0. Again, S1, S2, we have positive VDC. S1, S3, we have 0. This would continue. It goes to negative, then goes to 0, and this continues. Okay, so if we look at one period of this signal, so if it starts from here and again it repeats itself here, so now this is the voltage that we have here. This is the signal that we have here. Okay, so again, try to calculate its DC value and its RMS value, and calculate the AC value that you have, and see what's the difference between a half-wave rectifier and full-wave rectifier. So in half-wave rectifier, I'm sorry, I keep saying rectifier. This is inverter. Sorry, for a half-wave inverter and for a full-wave inverter. For a half-wave inverter, we only have 2 voltage levels. If you remember, it was VDC over 2 or negative VDC over 2. For a full wave inverter, we have 3 voltage levels. It can be either positive VDC, 0, or negative VDC. That would give us better AC signal compared to what we had for half wave. So this one actually looks more like a sinusoid. It would have, like, if you compare like both of them, we have like positive VDC, right? So if you compare this one and the output that you get here for full wave, you would see that it would have less harmonics compared to what we had for a half wave. So this is the whole concept of full wave inverter and half wave inverter. Okay, now so what's the problem with the thing that we have right now is that we cannot, in reality, we cannot have 2 things happen at the same time, right? So it's very difficult to turn this, I'm talking about S1 and S4, for example, right? It's very difficult to have 2 switches change states at the same time, right? There's gonna be some delay, right? So like if I, for example, I drop 2 things at the same time, there's gonna be some delay in how like in like some microseconds delay in when they drop. I'm just gonna give treats to my cats. So it's the same thing for the switches. So we have a challenge here. So we're gonna see a little bit later how this challenge can be fixed. So just give me some time to draw that. I'm gonna pause this.